Here is another ALEKS problem from homework 3. This time we're doing calculating the pH of a weak base with a strong acid. So this is the first time we're doing weak base with a strong acid. We've done a lot of weak acid with strong base, but remember I told you that we're going to take the exact same strategy. We're not going to do anything differently for this problem at all. We're going to start with our balanced equation, CH3, 3N. That's our weak base with our strong acid HNO3. And we need to write a balanced equation. So because CH33N is a base, that means it's going to take a hydrogen from the acid. So it's going to become CH33 and H plus, because it took that hydrogen, and our other product is going to be NO3 minus. And we're going to make an ice table, and we have to do this ice table in moles. So we need to start by calculating the initial moles of both of our reactants. We have 76.9 milliliters of the 0.87 molar base, 0.87 times 0.0769. That means we have 0.066903 moles of that guy. And for our acid, HNO3, we have 0.1100 molar and 660.7 milliliters. 0.11 times 0.6607. That is 0.072677. No products yet. We need to look at the quantities of both of our reactants and figure out which one we have the smallest amount of. We have the smallest amount of our base, CH3N. So that is going to be the one that goes all the way down to 0. 0.066903 minus x plus x. And this guy out here, we actually don't care about him at all. He's kind of like water. That's a neutral anion, has nothing to do with the pH, so we're just going to ignore it. So at the end, we have none of this. We have 0.072677 minus 0.0669903. We have 0.005774 moles of nitric acid and 0.066903 moles of our product. So whenever we get to this point in this type of problem, then we have to decide, how are we going to calculate the pH? Are we going to use Henderson-Hasselbalch, or are we just going to go straight to pH? In this case, we have strong base left over. Strong base, HNO3, is going to dictate the pH of the solution. So that is what we are going to use to calculate the pH. Because we have strong base, I keep saying strong base. We have strong acid left over. Because we have leftover strong acid, that's what we will use to calculate the pH. We would only use Henderson-Hasselbalch if we had this guy and this guy. So if we have these two, we use Henderson-Hasselbalch. If we have this guy, then we use pH equals negative log of H3O plus. Now, when I was doing one of these problems on my own, I messed up and I plugged the moles straight into the pH equation, and I got it wrong. That's not the right way to do this. You cannot plug moles into the pH equation. You have to plug molarity into the pH equation. So we have to take this 0.005774 moles and divide by the total volume of our solution, 76.9 milliliters and 660.7 milliliters. A total of 737.6 milliliters. or 0.7376 liters. The concentration, the molarity, is 0.007828. So the pH of this solution will be 2.11.